So what I'm doing here is constructing a table of values. We're going to approach our target value of x equals 2. So that should be in the center. Excuse me, I made 8 blocks here, so we need 9. So the 2 is going to go in the center. So what's this top row about? As we saw in the previous video, we can continuously zoom in and get closer and closer and closer. And it's a matter of the scale of which we do it. Now, as with most things in math, it helps if we do this in as orderly a fashion as possible. If we go equal distances to each side of 2 each time we move. So, on the left side, what we're going to do is go a full whole number, a full integer, to the left of 2. On the right side, we're going to go a full integer value to the right of 2. Now, from here we're going to close in a little bit at a time. So after going a whole number to each side, we're then going to go 1/10 to each side. We can then close in again and go 1/100th to each side. Again, why stop there? We can go 1/1000th to each side. Now, we can continue this as far as is necessary. How do we know how far that is? Well, the entire idea is to look at the output values and establish a pattern. So how far do we go? As far as we need to clearly establish a pattern. And not something that we look at and say, oh, I think this is going on. We should have solid proof, where if someone were to challenge you and say, how exactly is it you know that's 4? You should be able to tell them, well, because it goes like this. Now, how do we get the output values? Well, there are several ways to do this. Quite simply, to get the output values, you simply evaluate the function. If I want f of 1, I substitute that value into the function and evaluate it. Now, is there a faster way to do this? You bet you. I will have that in a separate video. So for now, I'm going to fill in these values from having done them myself. I will show you how I did them on the calculator in another video. So if we were to finish evaluating this function, we should get the value 3. This is where the calculator is going to start to come in handy. Evaluating 1.9 in this function will get a little hairy to do by hand. So again, we will be using the calculator to get most of these values. For now, I'm going to give it to you. The output value here will be 3.9. All of these output values are obtained by simply taking the x value and evaluating it, inputting it to the function and evaluating. Now, you'll notice I left the output value blank underneath the 2. That is, of course, because there is no output when x equals 2. This is where the limit comes in. The limit asks us to examine the trend of output values. to say as we get closer and closer to that target, we might not have an actual output value there, or we might. But regardless of whatever is or is not there, what do these values suggest you ought to see there? It seems that every time we get one decimal place, again, look at the values we're subtracting, 1, 0.1, 0.01, 0.001. Every time we get that power of 10 closer to 2, it seems like we just add another 9 onto here. Until eventually, we could have 3.999999999, etc. It sounds to me like we're getting pretty close to 4. From the other side, and one side is often a little easier to see the pattern than the other. From the other side, from the right side of 2, we start at 5, and then we go to 4.1, 4.01, 4.001. Much as we saw with the left side, each time we go a power of 10 closer, we seem to be getting a whole bunch of zeros stuck in there with just a 1 on the end. So the next level, if we went 2 plus 1/10,000th, 2.0001, we would get 4.0001. Another 0. The idea is that from the left side, if we could actually get to 2, and there was actually an output value there, it seems like there's pretty strong evidence to suggest that there should be a 4 there. From the right side, we get the same thing. Now, that does not mean the output value is 4. Again, there is no actual output value. But what we might say here is that based on the trend of output values, as x approaches 2, we might expect an output value of 4, and that's a key word there, expect. If x were to actually reach 2. Again, this is the concept of a limit, not dealing with what is actually happening when x is 2. In this case, there is nothing happening, but instead dealing with what the trend of output values around it suggests we might see there.